All right, so last part. We're going to start talking about now the large intestine. And if I can get this slide to advance. When we're talking about the large intestine, right, so again, we have the ileum being the last part of the small intestine. Food from there will flow into the cecum. After that, it will go up the ascending colon, so-called ascending because it's kind of going up, against gravity. There's a curve. We call that the right colic flexure or the hepatic flexure. Either term is fine. Then it goes across. We call that the transverse colon. Again, we're going to have a curve. That's the left colic or splenic flexure. And then food will travel down the descending colon. There's this it's a slightly larger area, but again, it's a smoother curve. We call that the sigmoid colon. Kind of see this curve right in here. It's almost kind of S-shaped, so sigmoid colon. And then we get into this sort of pouch area, which is called the rectum, then the actual anal canal, and then the anus itself. These, hopefully you can kind of notice this. You've got these sort of, I don't know, what do you want to call these sort of sections here. They're not true sections. They're just kind of like a drawstring, I guess. So, kind of if you like drawstring pants or a drawstring kind of purse or pouch or something, or even like a garbage bag, I suppose, it kind of will pull it together, but it's not like it's closed off in the middle. It kind of more forms these sort of like cubicle-like, maybe if you think of like an office cubicle-like separations. So basically, as food comes in here, it's going to tumble around into these different pouches, and these pouches are called haustra. And again, that tumbling is going to allow for some water absorption and still some processing by some bacteria. Okay. Let's see. The tinea coli is going to be a special type of muscle, smooth muscle. That's sort of the drawstring of the purse. So this tinea coli is what extends this light band that you see here in the middle. That's extending through the large intestine. That's what's causing the haustra to form. You'll have these little fatty and connective tissue appendages, like these little dangly bits. Those are just little bits of fat and connective tissue that dangle off. Attached to the cecum, right by the ileum, is going to be your appendix, called vermiform appendix. So called because it's small. It's kind of smaller than your pinky, kind of very earthworm-like. When we get down to the rectum here in this image and the anal canal, you'll notice that the actual anal canal and then the anus, the sphincter, the anal sphincter muscle, part of it's involuntary, part of it is voluntary. The voluntary part is what allows you to control when you defecate. But because it is skeletal muscle, as you get older, like all other skeletal muscles, it also tends to weaken. So, as you probably know, old people sometimes aren't so good at regulating bowel control, and that's part of the reason why. That is a very large rabbit. So I just want to talk to you a little bit about the cecum, and sometimes it's a little bit easier to talk about organs when we take them to like their extremes. So our cecum is fairly small. Like if you kind of form a U with your index finger and your thumb, that's about the size of your cecum, maybe not even quite that big. And in our cecum, we have lots and lots of bacteria that are going to help break down the last bits of food, particularly fibrous stuff, so like plant material. Now, in things like rabbits, and this is I think it's like a Welsh Rex rabbit, is what that breed is called. They are actually like scary big. And then they have a very large cecum. And then you're looking at a horse's digestive tract, and you'll see it also has a large cecum, which makes a lot of sense considering that they eat plant material, so they have to have lots of these bacteria that are going to help break down the plant material. Again, we mentioned this earlier. They are so like horses, for example, right? All that food that they just ate, all that grass goes through like their regular stomach, and then basically into the small intestine. But again, they are not as and I don't know how obvious this image is, but it kind of squiggles around and down into the cecum. Oops, like that. Um, they're not as good at digesting the food as cows were, because if you notice, right, all that grass has gone through the small intestine without the aid of all that helpful bacteria, and then all you have left is this large intestine to help digest it. Now, granted, again, you see modifications of their large intestine that we don't have. However, it's still not as efficient as getting that bacteria at the very beginning, like we saw in cows, to digest that plant material so that small intestine can really absorb all those nutrients. Okay. Again, that's why we're not so good at absorbing a lot of the plant material. There's certain things that you eat that kind of go out looking a lot like what they did when you ate them, because we cannot properly break them down because we simply do not have the enzymes to do that, and we rely on bacteria in our cecum to help us with that. So that little appendix that's hanging off of the cecum, so here you see a normal appendix, here's an inflamed appendix, and then when it ruptures, right, there's all this fecal matter that is going to infect. I don't even want to think about fecal matter being spilled all over the inside of your abdominal cavity, but as you can imagine, that'll cause massive infection, and because it's so vascular in our intestines, all of those bacteria are going straight into our bloodstream, and it causes sepsis, a blood infection, and it's deadly, right? So there's been lots of controversy over like what the actual function of our appendix is. Is it an immunological function? We see lots of lymphatic tissue in there. However, you can obviously remove the appendix, and there's very little effect on the immune system. It also stores lots of bacteria, good bacteria. So another theory is that it's actually a reservoir of good gut bacteria for us. So like, if you ever get sick and you have diarrhea, well, you're losing a lot of bacteria in that process. So the idea is that the appendix sort of is your reservoir. So like, let's say you lose all that bacteria, well, that you can repopulate your digestive tract via the appendix, or the population that's found in the appendix. And I think these days, with all the talk about probiotics in the news and on TV and in commercials, I think we're finally starting to really recognize and appreciate the importance of and the contribution of our gut microbes. Okay. Already mentioned all of these to you, so I'm not going to go back over that. We have basically the same histology that we have as well as we've seen in the past. So as far as chemical digestion absorption in the large intestine goes, there are no enzymes, so you don't have to worry about remembering any new enzymes. The only thing that the large intestine is going to secrete is just enough mucus to help keep things moving, along nice and smoothly. Again, we have lots of bacteria that are going to help ferment things. So different things that we cannot digest, it gets converted into carbon dioxide, methane gas. Undigested proteins get broken down by these bacteria. That's what gives, like, farts their smell, right? And remember, bilirubin is being added into the large intestine as urobilinogen and stercobilin, which will give, excuse me, Miss Sneeze. Excuse me, which gives feces its color. Those bacteria are also producing some very beneficial vitamins like vitamin K and B. Okay. You will absorb some electrolytes, sodium and chloride, for example, and then the last little bit of water that was left over will be removed in the large intestine, as we saw in that image in last lecture. So by the time you reach that transverse colon, that's the part where it's crossing over. Feces are semi-solid, and if you were to sort of dissect some feces, you would find lots of dead epithelial cells that have sloughed off from your digestive tract. Some undigested food, again, lots of cellulose particularly, and then bacteria. Our gut microbes, again, as we're finding out, very important, and they change. And interestingly, what we are finally realizing is that the means of delivery, the means of birth, will affect on the gut bacteria that babies have. So you can kind of see this. So if you have a traditional like vaginal delivery, you have basically the same bacteria that the mom will have like from the vagina. So a little bit of that will actually inoculate the baby. Versus if you have a C-section, you do not get all those sort of, I guess, probiotics that you get naturally. Rather, you're exposed to a different set, and which makes you more susceptible to different types of pathogens as well as other diseases. And then, interestingly enough, too, in your early adulthood, mid-adulthood, and then your elderly years, your gut microbes change again. So there's lots of new strains. So basically, early childhood, you have much more diverse flora of gut microbes, possibly because, and I think we're recognizing this now too, like if you take the gut microbes from different cultures, people from different countries even, based on their traditional diets or what they've grown up eating, their gut microbes can be very different. So in areas of the world where people eat a very diverse diet, you'll see a very diverse flora of gut microbes versus other areas where people, or even in populations where people are brought up eating, basically the same thing and not very diverse food, you see much simpler gut microbes. Okay. And then in the adult, again, you can pretty much tell the individual by their gut microbes. So everyone has their own unique set of gut microbes, which is kind of interesting, right? So you can actually tell, again, kind of an individual, it's almost like a fingerprint, okay? And then by the time you get older, your gut microbe levels also drop off, kind of, I guess, like everything else. You don't have as rich a gut microbe, and it's even more difficult to process certain foods. Okay? You don't necessarily have to memorize this image. I just kind of wanted to show it to you. So what you're looking at here on the top is going to be the lumen of your intestine. As you can see, there is a protective mucus layer in the large intestine. There's an outer layer, inner layer. So these are those epithelial cells that will line the inside of the lumen. And then this is basically on the other side of, on the inside, so, down in the mucosa layer. So what you're seeing here, this DC, these are dendritic cells, and hopefully you remember dendritic cells when we talked about our immune system, right? They were one of the antigen-presenting cells. So what these guys are doing is they're always sampling the bacteria. So basically they're kind of reaching through in between these cells and kind of are like, I don't know, I always imagine like if you stuck your hand, like close your eyes and you stick your hand somewhere, you're trying to identify what's out there. They're going to kind of sample the bacteria and go, okay, what bacteria do we have? How much of them do we have? And then they're going to take that information back to B and T cells to go like, all right, we've got way too many of these things, go back, or we have bad ones. We need you to go out there, produce antibodies, and let's take care of their numbers, right? So your body's kind of keeping their populations in check, which is kind of cool. And our bodies are not always great at it. Obviously we get sick, but for the most part, they do a pretty good job. Right? And it's going to be very important because, different disruptions can lead to lots of different problems. Inflammatory bowel disease, colon cancers. I mean, you've got a whole list. Obesity is kind of an interesting one. They've actually taken a look at the gut microbes in obese mice and thin mice, and they've noticed that there's a difference. And they've actually transferred the gut microbes from a thin mouse into an obese mouse, and the obese mouse lost weight. So it's kind of interesting how those will even factor into even things like weight and even mood and certain behavioral problems. So diet can affect your mood. Right. So defecation, so the actual act of pooping. There is a reflex that will move feces into this rectal area. There are stretch receptors that are going to send information to the brain going like, you got to go poop. And then it's up to you to then hopefully make it to the bathroom on time. And you have the parasympathetic nerves, again, the rest and digest, right? System is going to contract the muscles of the rectum and relax that internal anal sphincter And then you have, again, that voluntary control of the external sphincter. Now, again, take note that it is parasympathetic nervous system that is going to be controlling this, and you probably have all had the experience of, not being able to poop somewhere because you're nervous, right? There is, and people often say, like, yeah, but how come when something strange, or not strange, but like strenuous happens or anxiety invoking happens, people tend to poop their pants? Well, that's a slightly different response. That's more of your body dumping excess weight as a protective mechanism. Like if you got to run, let's get rid of all the excess weight. This way you can run faster. Kind of same thing with urination. Let's dump it and then run. Also, it's a bit defensive. Like most animals, if you're being pursued by something, if you soil yourself, like pursuit stops, right? Like whatever's going to try to eat you usually goes, oh no, that one's no good. That one's rotten. Like I don't want that one, right? So anyway, it's a protective mechanism as well as helps you get away. But for the most part, in normal daily life, if you're kind of just stressed out, you're not going to be able to poop. All right. So kind of going along with these gut microbes and all of that is basically how fiber is going to help you, and why everyone's always telling you to eat more fiber for proper health. So dietary fiber is in two different classes. There's insoluble and soluble. So insoluble does not dissolve in water. Soluble does. That's where those terms come from. But the importance and their use in the body is slightly different. So the insoluble fiber, you get that from the woody parts of plants. This is the part that you cannot break down. So this helps protect against colon cancer by keeping things moving along nice and smoothly. The soluble fiber has more of a gel-like consistency. You can find that in like beans, oats, citrus, apples, the white parts of apples. And the soluble fiber, why it's important, is it helps lower cholesterol by preventing the reabsorption of bile salts. Right? And if you remember, bile salts, a good large component of them was cholesterol. So by not being able to reabsorb cholesterol, you're basically pooping it out, which makes the liver have to use blood cholesterol to make more bile. So you're taking cholesterol out of your blood vessels where it could possibly, sediment and clog them, and you're putting it back into the digestive tract. And this, I love this so much. So what you're looking at here, and this is just a total aside, but oh my God, it is so cool. I think. So you've got like nature's perfect toilet. Like what? Yes, absolutely. Look, so this little guy is a tree shrew, and what you're looking at is it's sitting on this big pitcher plant, right? And so inside this plant is some digestive enzymes, and the plant's going to use whatever like falls into it. It'll digest that and use that for energy, right? Well, right here, this part is the lid. So this thing actually has a lid, kind of like a toilet seat lid. Well, on the inside, like of this lid, is this sweet, sticky nectar that it makes. So basically, these tree shrews climb on here. They flip open the lid. They lick off the sweet, sticky nectar. And while they're kind of just hanging out licking this off, they're pooping into the plant like a toilet. And basically, the plant then digests the tree shrew's poo for energy. How fun is that? So if you want more information on that, you can click on this link. You probably have heard of the Squatty Potty. If not, oh, you're in for a treat. Just go ahead and click on this link. It'll take you to that video. And basically what it's talking about is the angle between this puborectalis muscle and then your rectum. So if you look when you're sitting, this puborectalis muscle kind of kinks the rectum, right? Which obviously if you're trying to defecate, to poop, right? The poop kind of gets, I don't know, stuck or cut off, or I don't know how you want to phrase that. Versus when you're squatting, you have more of a linear line, is less of an angle, which allows poop to kind of be released easier. So there's lots of conversations about toilet heights and different ways to help by going to the bathroom, by having more of this natural squatting position than the sitting position that we have in, American type toilets. So yes, that's an actual thing. All right, so I hope you have enjoyed that, and I will see you next time. Please let me know if you have any questions.